So the interesting thing is the nose is because what's happening is we're telling it to move, and the physics engine is kind of figuring out momentum. So the nose kind of hits the ground. The nose kind of hits the ground because gravity pulls it down. So we can change things actually. So instead of using like rotate and translate, we can actually give it thrust.
Oh, so it accelerates?
Yeah.
Oh, okay.
So to do that, let's go back to the Unity manual. Where have we got the manual? There we are. So here, let's search for rigid body, because just like the translate, rigid body, as a component, it's got a class.
Roll. That is so clever. It rolled. I hit the brick, let go, and it's rolling around now.
What, the ball?
The gravity, the ball.
Yeah.
Yeah.
Yeah, it is.
Sorry.
No, that's right. Yeah, it's cool, isn't it?
Newbie experience.
No, it's all good. It's all good.
Yeah.
Yeah.
So go to the documentation.
Yeah. So when you're ready.
Yep.
From
body.
Rigid body in the scripting reference, you can just search for it. And you can see that it's got properties like angular drag and velocity, and so it's actually figuring these things out as it goes.
Mm-hmm.
And then in the public methods, we've got things like add explosion force. So if you want to have an explosion, like make bricks fly apart, you can do it. So we can add force, which will give it a thrust or a relative force. Torque for rotation. So these are things we can use. So instead of rotate, instead of like we were getting a reference to the transform, we can get a reference to the rigid body, and then we could use add torque to change to give it like angular force or angular rotation. So here we can do. In fact, here's an example where they're doing get axis and then they're adding torque. Now what they're doing here is they're calculating a vector transform.up. So around the y-axis, multiplied by the torque. Torque is where are you?
Uninitialized variable.
Yeah. So up there, so they've got like a torque. It's like a angular velocity, like angular speed that we have, and then turn, which is how far it's turning. So we can give this a try. How does that sound?
Yeah.
So if we go back to code, right? So back over here. So we can keep rotation speed. We should just change its, or we could delete it and create a new one. Let's call it. Actually, let's make a new. Let's call it angular force. Is probably the better. Angular force is probably a correct thing. 100 as a default value is a bit rough. Let's try 2. And then the other thing we'll need to do is get a private reference to the rigid body. So private, I sort of jumped around there, sorry for that. Rigid body, and so the rigid body class, I'm calling it underscore rigid body. In the start method, we need to initialize it. And again, Visual Studio 2022 is giving me perfect IntelliSense. So rigid body equals get component, rigid body as a generic. And then instead of using this transform rotate, we can get rid of that and do rigid body dot add torque. Now we can see here there's a few different a few different overloads or overrides. So for instance, in fact, if we go to the code, they should give us, there'll be other examples of it, but declaration, sorry, that's confusing, so I'll stay away from that. So here, let me do that again, add a bracket. Okay, so from the overrides, we can do things like give it a vector 3, which is what their code sample is kind of figuring out. We can give it, vector 3 plus a force mode, which is, we can choose what kind of force we're applying. or we can do add torque and give it X, Y, and Z values, which for us is probably the easiest, because we want to basically give it rotation only in the Y direction. Instead of calculating a vector and then applying that, we could use this version. So if we say 0 in the X, for Y we say Y angle, okay, I'm going to have to fix something here. That's got, get rid of that, it should have angular force. So the Y angle, or Y, maybe I should call this Y force. Comma 0. So it means that we'll figure out from the horizontal control, left, right, multiply that by a value for the, the base force value, and we'll soften it by time, and then that'll be our force we want to apply, and here we'll apply it just around the y-axis. Does that make sense?
I think so.
So what could happen here, right, when it collides and hits like a brick or something, gravity will still apply because of the nose.
Yeah.
The nose will actually drag it down. So it's still going to be kind of interesting.
Yeah.
But it means we'll just spin it like a top.
Oh, okay, yeah. So the torque's applying to just the ball and not the brick.
Yes. Yeah. Well, yeah. Just
the
that's
brick
right.
will still behave the same way.
Yeah. So when they collide, of course, the ball will apply force to the brick, including some angular, like the angular friction as well. So if the ball's spinning and it hits a brick, that'll probably make it not spin, but it'll make it skirt sideways a bit.
So you will get potentially more movement from the brick if the torque has been applied to the ball.
That's right.
Oh, okay. Now I'm getting it.
Yeah. Now there's a way of controlling this. So if we save this, so you're up to date with the code?
Yeah.
Yeah, sweet. So if we go to back to Unity,
Yep.
if we look at the auto bounce, actually we should change that. It's no longer a bounce, but anyway, we've got we can see the angular force is still 2 based on the default value. If I hit play, I'll probably find that the nose will drag it down, and if I spin it around. Okay. Now it's kind of, hard to see. It's actually not spinning a lot. Let me bring up the force, because it's probably maybe it's a bit low. I can't see it doing anything. Okay, that's not helpful. And what I can do here, in this situation where it's hard to know what's going on, I can actually switch to the scene view, and I can see it from the scene camera to see if that helps. The only problem is doing this, I can't access the keys on the key. Actually, you know what? Sorry, my bad. I might have been hitting the wrong keys. Let's try that again. Oh no, it is trying to. It's moving in the X direction. It's probably dragging on the floor, but it's not rotating much in the Y for some reason. Let me. Now I can change. I can just enter. So I've just chucked in 90 degrees as rotation in Y so I can see the nose. And now it's not moving very much. So the force isn't working out that well. What we can do is if I hit stop now, I'll stop the play. If I go to the rigid body, there's a field here called constraints.
Yeah.
So I can freeze certain things. So, for instance, I can freeze rotation around X and Z, and that should stop it rolling over so that the nose hits the ground.
Yep.
So that means that gravity won't apply. It means that it can only rotate in the Y direction. It can only spin like a top, but it can't spin in the other axes. So the nose shouldn't fall down. Because it's probably... The nose is hitting the ground, and then it's probably getting friction, so it's not moving.
Oh, okay.
So if
clever.
Yeah. So, but it means it's kind of realistic, but it also means that sometimes there's more things to think about. Now it's rotating better in the y-axis. Yeah.
Oh, okay.
And it's got angular momentum, so it's actually keeping it going. And if I hit, so I was doing right. If I hit left, then it will start swinging the left. and it's got momentum. So, if I change angular drag, because the angular drag is only 0.05, if I change that to be a bit higher, like 0.5, then we'll probably see that it will lose that momentum quicker. So now if I hit right and then let go, it should slow down all by itself, and it's slowing gradually.
Just changing my values.
Yeah.
0.5.
And you might want to turn on those constraints.
Yeah, I've done that. I haven't hit play yet.
Okay.
I'm just watching yours.
No, that's cool. And the forward and backward is still guided by the translate, so that's not working by thrust, but we can do that next. Yeah. Any questions?
No, I'm gonna run mine now.
Okay, yeah, run yours. I'll stop mine.
Turn around so I can see the nose. Yep. Yeah, cool. Yep.
Nice.
Yep. Bumping bricks.
Bump into bricks.
Yeah.
It gets fun quickly, doesn't it? You see things react and
Yeah.
nice. So let's go to the code, and then let's just change this. So we have our here we were calculating the actual movement. How much to move by in a single frame. So this time it'll actually be a speed. So let's change. I'm going to refactor this to call it speed, because this is truly actually speed. No, we can't use speed. I'll call it forward speed, because that's a better. Probably thrust is the better term, but anyway, it doesn't have to be exact. So now we have yes. Okay. So now we can get rid of the transform translate and do rigid body dot add force, and we should be able to do that the same as the rotation. There'll be a few overloads or overrides for that. So we'll do it 0 and X. We want to do it in Z. Let's see. Yep. Z will be forward speed. The interesting thing here is this might be relative to the world and not relative to the object. So we might find that it always moves along the z-axis, and so we might actually have to. We might end up having to create a 3D vector and rotate it by the current rotation, and then apply the force, and then it'll make sense. So let's see how it goes. I have a feeling this will just always move in Z. So we'll save that and swing across to Unity. And if we hit play, we'll know if we're having that problem by if we rotate the thing around. And then if I hit forward, okay, if it's always heading off in the distance, actually I can't see anything at all. Oh, it's very slow. I need to change the speed to be a bit more, try 50. Wow, it's super slow. It's adding momentum super slowly. Make it 100. And okay, I've got to get the rotation down to 0. Okay, not much thrust going on. What's going on? It's actually moving slightly in the X direction and slightly in the Z direction, so it's moving but really slowly. Okay, let's make this 1,000. There we go, it scoots off. Okay. Actually, it is moving according to where it's pointing, which is cool. Okay, now I've got to nullify. Okay, let's add some angular drag. Okay, 0.8. So that'll bring it right there. We go. That's easy. It should be easy to control with some angular drag, and it'll slip around like it's on ice because it's got no drag. Okay, come back. So now if I apply some force, we can whack into some bricks.
Oh yeah.
There.
Oh, come back. Yep. Hey, stop.
Yeah. So.
That's clever.
Yeah, it's cool. So if we put in some drag of about, I don't know, try 0.5 for drag, and I'm going to put 0.8 for angular drag. and then it'll probably be responsive but slow, you know, not go out of control. So for drag I've put in 0.5, and for angular drag I've put in 0.8. And if I hit play, and
I lost them. Oh yeah.
because you're still in play mode.
Yeah, I was
Yeah.
hitting the wrong button.
Okay, I've got to make that's right, I forgot, the speed needs to be 1000 before it actually does much.